Hey, Science Theories, and welcome to our final discussion or topic here in Unit B 2.3 Understanding Exposure. In the first half of the unit, we discussed a lot of the emissions that humans produce that are producing dioxins, dioxides. Jesus, Murphy. One more time. Hey, Science Theories, and welcome to our final topic in Unit B, topic 2.3 Understanding Exposure. In the second half of the unit, we've been discussing about a lot of organic molecules that have been produced by humans and their negative impacts on the environment. Generally speaking, these substances do not break down easily. And this last section, we'll be discussing a few groups of these molecules that are of particular concern when they get out into the environment. But before we do that, let's discuss a few of the ones that we've already talked about in this half of the unit. We talked about aromatics like benzene that are very difficult to break down. They were large components in things like gasoline back in the day. They're now also found in things like cigarette smoke. These are considered to be POPs, or persistent organic pollutants, that don't break down easily. Once they enter the ecosystem, they're very difficult to remove, and then they basically will move up the food chain through a process called biomagnification, which will be a topic of discussion here in today's topic as well. We also discussed halogenated hydrocarbons, specifically CFCs. Their release back in the day up till 1987, when they were banned by the Montreal Protocols, were a huge an issue with destruction of the ozone layer in the upper stratosphere that was causing increased UV radiation to enter the Earth's lower atmosphere. We also talked about other halogenated hydrocarbons like DDT, which is a pesticide, PCBs, dioxins, furans. These are all, again, considered to be, just like CFCs, they are persistent organic pollutants. They don't break down easily. There is a relative theme here. All of these substances tend to be very difficult to break down. DDT moves up the food chain. We talked about its impact on higher level predators like peregrine falcons, and how dioxins and furans and PCBs are all considered to be carcinogens when put into organisms. And then we also talked about esters, particularly plastics. Again, we know there's a huge issue with plastics, and you see these images of plastic in the ocean and how there's more plastic in the ocean than fish. Plastics, again, are designed to be very stable. They don't break down easily. There have been some innovations in areas like bioplastics, but generally speaking, plastics are a real issue because they are designed to be very, very resistant to decomposition or breaking down. So these are all ones that we discussed already in the unit in topics 2.1 and 2.2. Want to add a couple of new ones, a couple of kind of familiar faces. We'll be discussing fertilizers, we'll be discussing pesticides, among others here coming up in today's discussion. But let's first talk about paint. Paint, right? In your house, we use it quite often. You paint your house, you paint your walls, paint, cabinets, all sorts of things. Paints they have what a part of their chemical makeup are what we call VOCs, and we've talked about these before. Volatile organic compounds. These are ones that react really easily under right conditions. We talked about these volatile organic compounds that were released by automobile emissions that will then actually react to form smog and ozone at ground level. But in paint, these VOCs are also very heavily chemically reactive, and they can be released in homes when they are basically atomized. A lot of professional painters will use paint sprayers. This is a process known as off-gassing. And these volatile organic compounds will then remain inside the air, inside the home, because again, it is an enclosed space. And they basically will, overall, will reduce indoor air quality. Now, this is a major issue here in Canada because we spend a lot of time indoors, especially in the winter. We live in homes all the time. I mean, we sleep in them. So this is an issue. Not only is outdoor air quality an issue, which we talk a lot about outdoor air quality and how it can be compromised, but here's an example of where indoor air quality can also be compromised by something as simple as paint. Now, some of the newer paints out there do not contain as many of the VOCs. They're using now variations of halogenated hydrocarbons, in particular one that's used as 1,2-dichloral ethane. And they also use forms of alcohol now, like There's one that's used in particular, which is called ethane 1,2-diol. So these are kind of possible substitutes for some of the VOCs that were used in traditional paints, and will hopefully make things safer inside your homes, and to hopefully increase your indoor air quality. Another major group of pollutants, and we've already referred to them. I've talked about DDT already earlier in the unit. It was a form of a halogenated hydrocarbon. Pesticides are obviously used quite a bit agriculturally and in homes and in yards, but particularly by agriculture. Pesticides, one thing you have to discuss when you're discussing pesticides is what we call their target specificity. How targeted is their attack on organisms? We've talked about some that have very broad implications. DDT, which I talked about earlier in the unit, I've mentioned it here today. That was a pesticide used for decades that had a very broad spectrum attack. It would basically affect multiple organisms. So we're generally speaking, if we're trying to get rid of a specific pest in an agricultural situation or whatever the application is, the more targeted the chemical is to that organism, the better, because then you're going to have less fallout of other organisms being affected by that pesticide. So we would like to use as much as possible a narrow spectrum pesticide, but quite often we're using what are called broad spectrum pesticides, and they're promoted as such because they will remove a wide variety of, like for example, Roundup. This is a kind of a brand name that you might be familiar with. They pride themselves in being a broad spectrum pesticide because they remove a lot of different types of weeds that will occur in gardens or in fields or whatever. But that means that other plants that are not weeds could also be affected as well. So that is one implication that you have to be aware of. Now, there's obviously pros and cons to both of them. You may want to take a quick peek on this video right here about pesticides, just to kind of give you a bit of a look at sort of the whole political and I guess scientific ramifications of pesticides. Give that one a shot. Another thing about the pesticides that we should be familiar with is their toxicity. How dangerous are they? And there's a couple of values that we assign to pesticides. We have what's called an LD50 and an LC50 number that are associated with pesticides. Now, an LD50 number refers to the lethal dose that would be needed, the dose that would be required, the amount of pesticide that needs to be required to basically kill off 50% of a population of organisms that it's targeting. So if I needed 1 liter of Roundup, and that would kill 50% of the weeds in my yard, well, then that's the LD50 number of the Roundup that I'm using. There's also another number we can use, which is called the LC50 number, which is the lethal concentration 50%. That refers to the concentration, the actual concentration, molar concentration, whatever you want to call it, of the substance that is going to actually be lethal to 50% of the organisms in a population. So that's regardless of the amount. This would be, hey, if I have a concentration of this poison, how much, what would the concentration be of the poison that I would need to say kill, 50% of the weeds in my yard. Now, these pesticides get sprayed, and you probably have seen images of crop dusters that are dusting fields or whatever, or people just use sprayers in their yards or whatever. This will obviously have an impact on the spread of the pesticide. The pesticide may not be contained to just the area where the pesticide is being spread, because air will move substances from areas of high concentration to low concentration. And if we're using large amounts of pesticides, then the atmosphere gets involved, and the atmosphere can move these pesticides over very large distances. And in fact, there is a situation that occurs where we get depositing of these pesticides and other toxic chemicals through the atmosphere in a process known as the Grasshopper Effect. Now, the Grasshopper Effect basically means that these pesticides will, or whatever the toxin is that's airborne, they're going to evaporate when the air gets warm. It's going to basically get put into the atmosphere, and it's going to basically drift for large areas, for large tons of kilometers, I guess thousands of kilometers, hundreds of kilometers, or whatever. And when it gets to areas that are colder, like the Arctic, then the chemical that's in the atmosphere will begin to condense. And then at that point, it will actually come back down to Earth and will get deposited. So there are certain areas that are thousands of kilometers away from agricultural areas that are very heavily sensitive to this effect. In particular, the Canadian Arctic is one of them, just because of the colder temperatures there. That allows more of these chemicals that are being that are airborne, including pesticides, to basically work their way into the ecosystem of the Arctic and then get deposited there. And then once they're there, they kind of just hang out. And then again, that whole process of biomagnification occurs. Again, these pesticides are persistent. They are very persistent. We talked about DDT being, it's a halogenated hydrocarbon. We've talked about all these organic molecules. For generally speaking, they're very persistent molecules. So a lot of these pesticides are going to be classified as persistent organic pollutants. And that means they're going to get entered into an ecosystem. They're going to get magnified every time they move up the food chain. The plant gets eaten by the herbivore gets eaten by the carnivore, et cetera, et cetera. As we move up the food chain, that level of toxicity in the organism is going to increase. And we talked about this earlier in the unit with peregrine falcons and their eggshells and how they were affected by DDT. If you want to take a quick video right here, take a watch about what the grasshopper effect. What's the grasshopper effect all about? This video here will give you a quick little insight about an actual case that's going on that you can actually see. And here's a quick little map here of the grasshopper effect. Why does the grasshopper effect, why do we have the name the grasshopper effect? Because these pollutants will tend to hop. They will enter the atmosphere, then maybe get deposited down. Maybe it's winter, and then when the summer arrives, then they kind of get back, they get airborne again, and then they get deposited. So they can kind of jump from the atmosphere back to the ground, and then back to the atmosphere, and then to the ground, until they eventually reach a place that's fairly cold enough all year that they're not going to basically leave that environment. For example, the Canadian Arctic. Okay, so there's paints and pesticides. 2 more to go, and then we're done. Very short section here today. We got 2 more. We've got fertilizers and we got sewage, and then we're done. Fertilizers. Hey, you know what? Pesticides are horrible. So let's talk about something that's really, really friendly. Fertilizers. Fertilizers are good, aren't they? Yeah, maybe not so much. They might be good for the plants in your yard. They might be good for the plants that are in a farmer's field. But the fertilizer, again, is going to get, not all the fertilizer is going to wind up in that field. Some of that fertilizer is going to run off with the water that enters that field. It's going to get put into watersheds. And when that fertilizer enters an aquatic ecosystem, all sorts of things can happen. Now, this is something we've discussed in Science 9. I discussed this with you if you took my class in Bio 20. This is a process that we call accelerated eutrophication. This process is where all these nutrient-rich fertilizers that contain nitrates and phosphates are going to enter a watershed. And what that's going to do is it's going to provide a lot of nutrients in the water for algae blooms to get started. Now, algae, well, maybe that's a good thing. You got food for organisms in that ecosystem. That may not be a bad thing, but in fact it is. Because a lot of algae will produce toxins that will actually enter the water and will actually cause, kind of a more toxic environment for organisms living there. But more importantly than that, when the algae blooms eventually die, once the algae breaks down and dies and decomposes, you have decomposers that come in there, and those decomposers are going to basically decrease the oxygen levels in the water, and this is going to be a major problem. No oxygen in the water, that means larger organisms in the water, like larger fish, are going to basically succumb and they're going to die. There is one particular time when this really becomes an issue, and that's basically right at the end of a growth season, like in the summer. It would be right at the end of the fall, going into winter, just as all the algae that was growing in that pond over the winter begins, just before the winter freeze happens, and all the algae begins to die. You will get what's called winter kill. And then right before the winter, or during the winter, then what will happen is the oxygen levels in the lake will plummet because of all the decomposition going on, because of all that extra algae that was there. So we talked about acid deposition and how there's more of a danger with acid deposition in the spring for your pH to drop in the spring, because the snow that's acidified on the lake will then melt into the lake. So we get a higher influx of acid deposition in the spring, we get a higher rate of oxygen drop off at the end of the fall and into the winter when all the algae in a lake will die off. So there's different times of year where the lakes could be susceptible to different things. And in this case, winter kill, as the name implies, is going to be a drop off of oxygen right before or during the winter. But again, this process known as accelerated eutrophication is not good, not going to help anyone in the aquatic ecosystems. If you want to take a quick peek at the video right there, accelerated eutrophication, everything you need to know is going to be right in that video right up there. And this slide right here, great slide, is going to show you sort of the process in a graphical format, sort of a diagram format that kind of shows you what's happening and why that's occurring. So that's, again, just one of the dangers of excess amounts of fertilizer. Our final topic today is going to be about sewage. Sewage, like fertilizers, can reduce your oxygen levels in the water. It will also increase the risk of exposure to pathogenic bacteria, viruses that can cause a host of issues and medical conditions, everything from dysentery to cholera. If you want to see a little bit more about cholera, watch the video right there. There's types of bacteria like E. coli that can actually enter the watershed with sewage. That has been a real issue with E. coli poisoning in certain communities. Walkerton, Ontario had a massive E. coli outbreak a couple of decades ago, and quite a few people actually died from E. coli poisoning in that community because E. coli got into their water system. So that's an issue. But let me kind of circle back to the oxygen issue with fertilizer for a second. Like fertilizer and like sewage, both of them are going to reduce my oxygen levels in a watershed. When that happens, as my oxygen levels decrease in an aquatic ecosystem, at the same time, what's going to increase will be something called my BOD, my biochemical or biological oxygen demand. It makes sense. If I reduce the amount of oxygen in a lake and I've got a whole pile of organisms living in that lake or that pond, the demand for the oxygen, the limited oxygen that's now there, is going to obviously increase. And that's going to be a bad thing for the aquatic ecosystem because now there's not as much oxygen available for the organisms there. And some organisms are going to obviously perish because of this lower amount of oxygen. So just be aware that there is an inverse relationship, between oxygen levels in an aquatic ecosystem. When they go down, what is called my BOD, my biological oxygen demand of that ecosystem will increase. So you should be able to tell me, like if I tell you, if my BOD increases, then what happens to my oxygen levels? Well, that's going to be, my oxygen levels are going to decrease. I should know, if I know one, I should be able to tell you what's happening with the other in that relationship. All right? And I think that is it. There are some questions coming your way today. There's a few of them, so hang on to your hats and here we go. I would like you to complete practice questions 27 and 30 on pages 284 to 289. I'd like you to answer questions 1, 4, 5, 6, and 8 on page 299 of the textbook. And I would also like you, as part of the review for the upcoming quiz, now that we're done our topic 2.1, 2.2, and 2.3, I'd like you to work on questions 1 to 6 and 8 to 15 on page 301 and 302. All right, that's it. That's the unit. Next time I talk to you, we're going to be switching gears. We're moving over to the physics component of Science 30. We're going to be discussing electromagnetic energy, electrical fields, magnetic fields, the electromagnetic spectrum. Big numbers coming up. Don't forget to have your scientific calculators because you're going to need them. Lots of formulas too. Maybe a little bit of Einstein in there as well. That's it. We're done. The organic and the acid deposition sections, the chemistry sections of the course. Hope you enjoyed it. Till next time, guys and gals, have a good one.